Here's what we're looking at. So we know the trapezoidal rule, and we know by cheating and actually using a graphing utility to compare the areas that we ended up with, obviously with better approximations when we added more trapezoids, right? Because we compared it to the actual accurate numerical result that we get from a graphing utility. But without a graphing utility, how would we know how accurate we are? Okay, so there's the dilemma, right? Because this is an approximation method that's seeking to, we can't find a method, we can't find an area analytically. There is no antiderivative, but we have to have some idea how many trapezoids are enough to get the job done, right? And so it turns out, there is a method for figuring out what the maximum error would be. Okay, it's kind of a weird formula. It looks like this. The error associated with the trapezoid rule is always going to be less than or equal to the quantity b minus a cubed over 12n squared. I think that's the coefficient. I got to double check that. Yeah, it is. Okay, times, and this is the weird part, times the maximum of the absolute value of the second derivative of the function on your interval, okay? So that's a weird animal right there. We'll talk about that. Okay, and then this is going to be on your interval. Okay, so let's take an example. Like, what if we had, for example, let's say we want to determine n, and what's n going to be?
The amount of trapezoids.
Yeah, number of trapezoids. Okay, so determine n. So that the trapezoidal rule will approximate the value of the integral of the square root of 1 plus x squared dx from 0 to 1 with an error less than 0.01. Okay, so we need to know how many trapezoids must we pick for our approximation to be at least that accurate. Suggestions?
Plug everything into the error trapezoidal rule and solve for n.
Okay, so we want the value of this expression to be less than or equal to 0.1, right? Because that's the expression that's going to give us the maximum error trapezoidal rule will yield, right? Okay, so a lot of this is, like the first part's, n's what we're trying to find. That's the unknown. A and B we know, right? What's A?
0.
What's B?
1.
1. Okay. We know what's f of x? Square root of 1 plus x squared. And so then we've got to find the maximum of the absolute value of the second derivative. Okay. So let's do that one. So if f of x equals the square root of 1 plus x squared, what's f prime of x? 2x, good. So we have chain rule issue, don't we? Okay, and I could go ahead and cancel the 1/2 and the 2. That's kind of nice, right? And then I just end up with, what, x divided by square root of 1 plus x squared. Okay, so there's the first derivative. Right? Now I gotta take the second derivative. So what's that gonna look like?
Can you show up a little bit?
Okay. Okay, so what's the second derivative gonna look like then?
1 plus x squared to the -1/2.
Okay, so you're gonna use the quotient rule? Okay. So low D high times, what's D high? 1, okay, good. Minus high times D low, which we already did, didn't we? Right? The derivative of 1 plus x squared is that, right? We already did that in the first step, okay? Okay, all divided by the bottom squared, right?
Which means that would be 1 plus x.
1 plus x squared, good. Okay, so then we can simplify this. Let's see, this is just gonna give us, if I get a common denominator here of the square root of 1 plus x squared, that's one way to look at this. Wouldn't I just multiply top and bottom by that here, right? So does everybody agree then we're gonna get from this term, so we'll go ahead and put a circle around that so we can keep track of where that minus sign is, separating the two terms. So we'll end up with 1 plus x squared minus x times x is just going to be x squared divided by our common denominator, 1 plus x squared, right? All over 1 plus x squared. Okay, everybody good with that? Okay, once again, we just had to get a common denominator between these two terms, we had to multiply the first one by the square root of 1 plus x squared divided by itself, right? Okay, so then if we combine everything up here, right, we're going to end up with, in the numerator, so all this stuff, what kind of color code this? All that stuff just becomes 1, right? 1 plus x squared minus x squared. Okay, divided by, well now what if we combine all this stuff? Right? If this is in my denominator and then I'm going to also divide by 1 plus x squared, it's the same as multiplying by its reciprocal. Right? So everybody agree I'm going to end up with 1 plus x squared to the 3/2 on the bottom. That make sense? So the step in between, the step we get there is 1 over square root of 1 plus x squared times the reciprocal of the bottom. Right? Which gets us there. Okay, so there's the second derivative. Okay, so now on our interval goes from 0 to 1, right? The absolute value of the second derivative. So if x is positive, right, x is, well, non-negative, it's going from 0 to 1. Are there any places where our second derivative would ever be negative valued? No, it's going to be positive valued everywhere, right? So we could say that this is really the same thing as saying the absolute value on our interval, right? If we're going from A to B, from 0 to 1, right? So then we've got to figure out what's going to be the maximum of our second derivative, of the absolute value of our second derivative on that interval. So let's look at the behavior of this, right? So we know that the absolute value of the second derivative equals 1 over 1 plus x squared to the 3/2. Now, where is the fraction going to be maximum value on the interval where x goes from 0 to 1? And why? And just think about the behavior of a fraction with a constant numerator.
Is it gonna be 1, the maximum?
When x is 1?
No, when x is 0.
When x is 0, right? That makes sense, doesn't it? Because that's going to make the denominator a minimum, and small denominator means big fraction, right? Everybody agree? So the maximum value of this is going to equal 1 over 1 to the 3/2, which is just 1. Okay? Everybody agree? Okay, it's going to occur. Oops.
Wow. So 1 trapezoid is the best.
Right. So then, now we know, so the value of this, if we kind of just plug in what we know, this was the hard part, right? That value is 1. And so then the equation we get, if we just go to the next page, equation we get is just this, right? So we know that b minus a cubed over 12n squared times 1 has to be less than, didn't we say it had to be less than 0.01? Wasn't that an error that's less than 0.01, right? Okay, so then we just plug in 1 for b and 0 for a and solve for n, right? So that's just going to give us 1 cubed. So we essentially just get 1 over 12n squared is less than 0.01. Well, what are the steps I'd go through, just algebra here, to solve for n? Okay, I could multiply both sides by 12n squared. I could do that. One other thing I could do is I could just flip both fractions. Okay, but if I take the reciprocal of an inequality, if I take the reciprocal of both sides, what does that have to do to the direction of the inequality sign? It's got to flip it, doesn't it? Let's take an example. Like, wouldn't you agree that 1/4 is less than 1/2, right? But if I flip both sides, I'm going to get a 4 and a 2. Obviously, we have to reverse the direction of the inequality, don't we? Right? So when I take the reciprocal of both sides, I'm going to get 12n squared is greater than 1 over 0.01. And we could just write that. What is that?
100.
100, right? But you don't even have to do that. I mean, you're going to do this on a calculator anyway. So you could even just leave it like that if you want to, right? Then the last 2 steps to solve for n, divide by 12, right? So n squared is greater than 1 over 12 times 0.01 is just 0.12, right? And you can write this product if you want to. And so then I'm just going to square root both sides, right? And obviously n is an index, right? It's a number of trapezoids. So when I square root both sides and I get a plus or minus, I mean, what am I looking for?
Plus.
The plus, right? N can't be negative. It's a number of trapezoids. So n would have to be greater than the square root of 1 over 0.12. What is that?
2.8867.
Is that right?
Radical 3/6 if you made the 1 over 0.01 100, it becomes 10 radical 3/6.
Do 100 above and above.
That's, yeah.
Oh, hang on, I divided by 12. So that's, I did that wrong. That's not right.
That looks right.
Divide by
Pretty sure it's
12.
right. No, yeah, that is right.
Why don't we just make it 100 over 12?
Yeah.
It's a lot easier to look at.
Divide each by
Yeah.
4, and then we have 25 thirds.
No, it's okay, same thing. 100 over 12, same thing, isn't it? Yeah, no, it's right. Everything's right. Okay, so that gives us what for an answer?
10 radical 3/6.
Okay, what is it as a decimal?
2.88.
2.88? Yeah. Doesn't seem like very many.
2.89.
2.89. Okay, so then if n has to be greater than that number, what's the next integer up? 3. That seems really like a small number. Oh, that's right. Yeah. Okay. So we'd have to have at least n equals 3. Could we have more than that?
Yeah.
Sure. But that's the minimum number we'd have to
And
have.
that, I guess that function just doesn't need that number.
Right, right. So we didn't need many. That was a pretty flat topped function evidently. Okay. Yeah, that makes sense. Okay.
So it's because we set x equal to 0.
Does that make sense?
So this would just.
You got that? So that's the last thing then. We've got this one last piece to this, which is the error approximation rule for the trapezoidal rule. So I broke that section. It's section 4.6. Part 1 is just using the trapezoidal rule. Part 2 is applying the error formula. Okay. Have at it. Try it. You'll have questions, but I'll answer them if you have any.